So yeah, my name is Chris, and I'm here to talk about how you can create spontaneous AR interactions with ARCore and instant apps. So before I start, I just want to know who I am talking to. So how many of you can describe yourself as developer? So coding experience and all that stuff. Okay, it seems like almost everyone. And okay, so how many of you heard about ARCore? Okay, pretty good. And instant apps? Oh, that's surprising. But maybe there was a talk before, right, about instant apps as well. Can someone nod? Or say yes if there was before? Yeah? Cool. Okay, so I used to be a software engineer. I spent most of my time working as an Android developer. But for the past year, I've been working more as a product manager and focused on VR, AR technologies in general. Yeah, in my free time, I'm a sports climber. I don't know why I still have it here, but if someone wants to talk to me afterwards, then climbing is one of the topics you can also approach me about. And currently I'm working on my personal brand called vRational, which is related basically to VR, creating apps for VR, AR machine learning. Okay, so I saw that not everyone know that what is ARCore. So just to give you a brief introduction from Google. Okay, we don't have a sound. Not sure why. Oh yeah, on my computer. Okay, so this is like a promo video from Google, how they market the ARCore technology. So what's important here, this is AR, which is 6 degrees of freedom. So basically you can move and the AR content will stay in place, like in a physical world. So like, yeah, for instance, you can snap an Android robot to branches and it will stay in place. And ARCore has even more possibilities because they also estimate light. And you will see it later in the examples I will show you why it's useful. And it tracks basically horizontal, vertical planes. And yeah, and it's all done only using a single RGB camera from your phone and sensors, accelerometer and gyroscope. Okay, so what this whole spontaneous AR interactions are about. So I will start with a video. So this is an app which I created. This is my business card, my personal business card, which I can scan, like with a regular QR code scanner. It opens my web page, and then I have this information about AR experience. So then it opens basically the instant app. An instant app is something which doesn't have to be installed on your phone. It's downloaded on the fly when the experience starts. And it can be invoked from a browser, it can be invoked by NFC tag, whatever, like anything that can just open a URL can start your AR experience. So what's next? Because I had to divide it in two videos, because this instant loading app, which you might have seen, like shows only one time. Later on, I saw that this instant app is also cached. So this is the whole experience. So, and this is what this all is about. So basically, how you can create e-commerce apps that reacts to the same like business card. Actually, the other side of the business card. And yeah, this is like how you can, for instance, use it in the shop environment. you can like show put a flyer for your customer, and the customer like will be able to see a 3D model, whatever you want to sell him. He can even try, might try to see if it fits like his hand or her. There are some like problems with tracking once you try to put your hand in front of your phone camera. But yes, more or less, I just want to give you the experience, the whole experience. And what you will see on the right, there is a small panel. So this is not just for showing AR content, this is just how you can create a whole pipeline from engaging user into AR interaction to increase your sales opportunity, to display some other possibilities. And then there was a button called buy. And once the user clicks it, then he or she gets redirected to either a web page or a full application, so he can install also a full application version and then continue the checkout process there. So in general, the whole concept and the whole presentation is about this. But I will tell you more about this, how you can create it by yourself. So first, before you start even thinking about developing for ARCore, I think it's really good to set up yourself an environment. And current Android emulator has ARCore support. I will show you it during the demo how you can interact with emulated version of ARCore. There is something called Google Scene Form Tools plugin, which is also good if you want to see how your models will look like inside the Android Studio. And basically it also helps you compile all the assets for ARCore. And nice to have, but not necessarily, because you can, most of the time you can work inside the emulator, is to have ARCore enabled phone. But yeah, so what is Scene Form? Because I told you about ARCore. ARCore basically is this whole framework that you can use to create AR experience, which is like this word scale AR experience, so you can move around it. But Scene Form is a toolkit which you can use to easily create AR experiences without not much, I would say, gaming knowledge. And just to give you another example, this is also like invoked through this business card, but just to give you like more examples of what can be done also with Scene Form. I also created like 3D version of my business card. So this is like a regular ARCore session, and once you scan the floor, then you can see like this is also created in Scene Form, for instance. And there are a couple of things which you will not find, I think, I couldn't find it anywhere. Actually, like this moving shape, this is something which was done procedurally and with custom-made materials. But this will come later. So what this all is about? The whole Scene Form apps are about arranging 3D scenes. And there are a couple of things you need to know. I think they are the most important one related to this Scene Form toolkit. These are nodes, and nodes are basically how you organize your hierarchy in your scene. So there are child, parents, there are basically objects which you put in 3D environment. There are a couple of cool things which helps you build AR experiences, like this view of buying phone is a view renderable, which can be done using a regular XML layout, and model renderables, which are like basically how you import 3D models into the scene. And there is a custom renderable, which I will show you, which was the one, this triangle moving geometry, which you have seen in the video. So another important thing which you also need to know about Scene Form and in general about ARCore, that they have their own rendering engine. This is based on Google Filament, but this invokes something called PBR rendering, which is physics-based rendering. And you might have noticed on this watch that it was reflective. There was a glass like shape. There was even some like normal bump map. So you can basically render 3D objects which really look natural. And there is a way also inside this SceneForm SDK to write your own materials. And for instance, this moving geometry, that's the material which I will show you how to write. So now I would like to, and like be gentle with me. This is like a live demo, so I want to show you a couple of things related to that. Because as I can imagine, most of you are Android developers. Is it like a good size, or should I make it a little bit larger? Larger. Okay. Is it enough? Cool. So yeah, most of you will recognize this code if you are Android developers. This is just a regular activity, which is, and there is only one activity to invoke whole experience. And regular activity has like a content view which is loaded. There is a fragment, and this fragment is from SceneForm, which basically supports whole AR session. Yeah, there is some commented code, but this comes later if we have time. So the most important part, I will start with the watch. So watch was, like as you could have seen, it was like displayed on this business card. And it had to be loaded, so there is something called smartwatch. And once it's loaded, it's put it into the scene. And it's put it into the scene once you create a node, which I told you about. Once you set a parent, so you put it into the scene, which was basically generated through this fragment. And like there are a couple of things related to setting local positions, so you can basically modify the scale, the position, rotation of the objects. But like this is like depends on what you need. So what this watch is exactly, because you see like a smartwatch 2, which is in my resources. So smartwatch is like basically FBX model. This is like a standard 3D model format for basically general 3D game, creating 3D games basically. And I don't want to go too much into details about how you create those descriptor files, which helps you load like this models, meshes basically. But the important stuff here, that there is something called like material. My custom, like one of the custom made materials, and just to give you an example of how it looks like, there is a material. It's very simple. How many of you wrote your own shader in the past, like GLSL shaders or whatever? Only a couple of people. So there are two things which are related to shaders. So we have two types of shaders, like basic types. And one is the vertex shaders and other are fragment shaders. So basically, vertex shaders, once you have a 3D model like this one, like this watch, it is a mesh. It has vertices, it has many triangles. So vertex shaders, they allow you to modify on the fly the properties of the vertices, basically. And fragment shaders are some which are involved for each triangle, for each pixel in the triangle. So whole colors and reflections come basically from fragment shaders. And in this particular example, you can see that all those colors are basically initialized through the textures, which were also supplied by the model. Don't want to go into much details, but there are a couple of properties related to how you can render these PBR models, and they are basically base colors, metallic properties, roughness properties, and I think that's the most important one. So especially this metallic aspect, this is something which gives this glow. And this is what makes your models inside like those ARCore experiences look really natural. So yeah, so this is like a model. And coming back, because just wanted to tell you what this exactly is. It's loaded into the scene, and there is a way on how you will put this watch onto the scene. So I told you that I used my business card. So another thing which I want you to know is something called augmented image. I will have more slides in the presentation, but the way it was positioned on this business card was through augmented image. And there is, like, this is like a basic code. I don't want to, like, show it to you now, but this is something you will definitely find easily in the internet. And you basically put the watch node on this augmented image, which was found in the scene. Okay, so that's all about the watch. And next to the watch, you could have seen this view. And this view is basically made using a simple layout. Watch by view, XML. So this is something which most of you probably are also familiar with. This is a regular XML file, and this is like a simple view which you do traditionally, but thanks to Synform SDK, you can load it. And you load it exactly here. Like, you load it basically the same way, similar way to how you load models. You set this layout as one of the parameters, and here you just put like a basic code like basic logic to your layouts. So this is like can be done traditionally. And now think about an app you made recently. So basically, the only thing you would have to do to move your app, like a regular 2D app, to I would say AR 2D app, because those planes are still flat, not 3D, is to just basically wrap it in view renderable. I also experimented with fragments, so you don't have to like have a logic inside an anonymous function. You can also do it using fragments and like separate your logic in a different class. Okay, so this is basically how you combine two things here to create this watch, which is visible in this AR experience that I showed you. And yeah, so this is how you organize your scene. This is like how you generate your model. There is a code on how you position basically those models. I just want to show you. Like basically, you just use this to position it in the scene. So you can move it to the right, move it to the left. You can put it really high in the air as well if you want to. Okay, so this is about those basic shapes. And I showed you that there was this moving, once just to remind you, this moving shape, this one. And this is something which you will not find definitely anywhere in the internet, at least so far. So this is something which was done procedurally. So basically this is shape which is generated on the fly. And actually it will be, every time I launch an app, it will be a little bit different. Okay, so there is something called renderable definition. Once again, I don't know why it doesn't remember the size of the fonts. So yeah, more or less I think it's the same size as before. So this is something which you basically create like, before we were loading a mesh which was already generated. Here, we generate the mesh. And we generate mesh like using vertices. So we create random vertices in 1 meter square sphere actually. And we generate triangles. So some of these vertices are basically connected with edges which create submeshes. And this is where you just basically create a submesh. So once you have a submesh, I have two submeshes because there was red submesh and there was a violet triangles in this model. They are created, and this is like the last step of this is like renderable definition, which is created using custom initialized vertices and those meshes with the triangles created on the fly. So this is it, and this is how you create the basic shape from the code. That might not look really nice because definitely, like just to create this sample cloud of triangles, you need at least this much code. But yeah, just to show you that this is also possible because like this is what you can do in the 3D world. So basically, you can generate 3D objects as well using Synform SDK. Okay, and now another thing which is also not very, it's not very easy to find. That's what I would say. I told you about those vertex and fragment shaders. So fragment shaders are used for color. So it's easy to create like a material, basic material with just a color. And yeah, actually I had also a code for that one. If we, for instance, uncomment this one, yes, red material, and we will launch the app with this one, with this code, then you will see that this shape will become static, because this will be a regular static fragment shader without vertex shader code. And yeah, I'm not sure. Yeah, that's a demo effect as usual. Yeah. And I think the problem is also that they asked me to record the screen, so my computer is actually really hot at the moment. So I'm not really surprised that it stopped working, like emulator stopped working. Probably there is a very low RAM here. Okay, yeah, there is something, as you can see, a pop-up here. So I hope, yeah, I wanted to show it to you, but probably can't. Yeah, okay. It took some time, but oh, there is a watch. And now you can see those red meshes. They are now not moving. Only violet ones are moving because that's the shader which I created. The red ones are static. So one thing that changed between like a regular fragment shader, like a regular standard material, is just I added the vertex shader. And you know, like I don't want to go into much details about vertex shaders. But it's really easy to find how you can write vertex shaders. And this code basically, in every second, like in every fracture of second, it modifies the position of vertex slightly. And this is how you basically at the end get this, there is a sine function, so basically this is how you get this floating effect of triangles. Yeah, so this is something which is not easy to find, basically this, that you can use material properties, and in this case volt position, which is like a position of the vertex, and you can modify it on the fly. So if you get to the point where you really need to write a custom material for your models, this is how you do it, basically. Okay, yeah, so for now this is what I had for you in a demo. We will maybe go back into Android Studio as well. But yeah, just once again, I think I already told about this. Like I showed you in Android Studio how it looks like, these materials things. Okay, so what are my recommendations for working with SceneForm basically? I think it's still, they are still developing those frameworks. So I think it's really good to be up to date with your Gradle dependencies. I've seen some strange things when working in emulator when I wasn't doing that. There are bugs which are fixed almost on a daily basis with those SDKs. So it's really important to keep all the Gradle dependencies up to date. Also, it's really good to update the Android system image, which you use in your emulator. And there is also ARCore emulator version of the app, which is also really good to, like you need to go to the ARCore SDK page, and then this is where you can get the ARCore services APK for the emulator as well. Okay, so now I want to go much more into details when it comes to augmented images, because ARCore is something which you can basically launch on your floor, on the wall or whatever. But there is also something called augmented image. And in my case it was my business card. But you will see the example of how you can use a poster to create AR experience as well. So this is like a regular poster, but once it's looked at through the phone with AR app, it can be transformed in a 3D form basically. And yeah, this is just like to give you an example of what you can do with AR and 3D in general, and I think it's really cool because you can actually create even a new space, because the wall was flat, the poster was flat, but here you can see that this dimension, this digital dimension goes into the wall as well. So you can think about creating some sort of magic portal to Harry Potter world as well, for instance. Yeah, so what you can do, it's actually really easy to create an augmented image. So in my Android Studio, I have this back image of my business card imported, and at the bottom, I don't know if you will see it, but here, this is like a tool which is also delivered with augmented image. If you like type in Google augmented images, and you go to developers page, then you will find this tool as well. So this is basically how you can evaluate if your image is really good for AR experiences. And in my case, it's 5 out of 100. So Google actually recommends, oh, I have it somewhere, but don't know which, maybe later. I haven't added it yet. So Google recommends images which are really highly featured and with not many repetitive features. So this is not like this sort of carpet is not a really good augmented image, but something, I don't know. Oh, this patch, I saw it's quite interesting. So this sort of pattern where there are many different features, that's something which can be used for augmented images, and it will work much better than, for instance, business card like this with a lot of white and just a couple of triangles. And once you evaluate if you have a really good augmented image, then once again using ARCore image, you can create a database. You have to do this because this is like they transfer the image data to their own format, which is recognizable by ARCore. Yeah, so once again, you just use this sort of ARCore image command, and you build database with your path to your images. So you basically create a folder and put all your augmented images there. And you can see that once you create the database, there is still information about how your augmented images will be named. And why this is important, like you will see in a moment like why is it important to know the name of your augmented image. Okay, and just a simple code which you use to load the database. Nothing fancy, you can just, like using the delivered SDK, you can just load the database image, and you need to set it in your session, AR session. This is like config, session config, set augmented image database. Easy. Nothing fancy. Okay, so here comes, I already showed you like a preview of this code when I was just explaining on how this watch is attached to this business card. So the thing that I still haven't mentioned is how you actually identify the augmented image, because you can have, I think they say that you can have up to 1,000 augmented images. And how then you basically, depending on the augmented image, on how you create a different kind of experience. So here you can see that there is augmented image get name. So this is something which is like during the AR session you can like get the information about what was actually tracked recently, and then you can compare it to the name. So that's why I told you that it's really important to see what are the names to your augmented images which you put into your resources. And yeah, and this is how you can differentiate between different kind of experiences depending on what you actually track. And yeah, I haven't done more because I wanted to like add more markers, like a different, I wanted to use the different side, like this regular side, front side of my business card. But this, when I tried to evaluate this using this ARCore image command, gave me 0. So this part of business card cannot be used as augmented image at all. So that's why I only have one experience for you. Okay, and now instant apps. Because that's what's really interesting about the direction which Google is actually now going into, is that we don't have to install apps. And like I see this as a problem because most of the apps are now like more than 30 megabytes, sometimes 100 megabytes, and you have to download it. And it's really hard if you, for instance, if you are in a tram and now you are looking for an app for buying a ticket, I would rather like on the fly get an instant app version of Skycash just to buy a ticket instead of installing it. So this is how you can like shorten the time of how your user actually gets the action done. And yeah, so I thought since AR is not really popular, so not many people are aware that you can create this 3D cool AR experiences that maybe it can be combined with instant apps. So instead of like marketing that you have now a really cool AR app which can be used, and then you can see like all those watches, like luxury jewelry inside this AR application that I don't know, like Bytom can make, or Swarovski, sorry. Then you can just like get him on board with just a simple flyer. But there is a but. This is how I feel about creating instant apps. So I tried it. I think I spent much more time creating an instant app than I spent creating the AR application. So I wouldn't want to once again like create an app from scratch, and I will just show you the process. So the part which is done in Android Studio, this is pretty straightforward, because you just need to create flavors, and then you create 2 flavors for your app, one called instant, and the other one which is like a full version of your app. And so this is what you need to configure in your Gradle file. For instant app, if you have a really small app, then it's just enough to have Android manifest. This is like a specific manifest which has to be like this particular Android manifest, because this is how Google understands that this is an instant app version of your application. And if you have a really large app, then you have to split your code, and then you have to like put only the necessary amount of resources and classes inside instant flavor, and then all the rest in the installed version, like a full version of the application. And then it's pretty simple, just because you need to, instead of building a regular APK, you need to build a bundle. And you build the bundle for both flavors. So you will see like 4 flavors, like for debug and release versions of instant and full version of your app. And yeah, once you create the bundle, then you just need to sign it. And Android Studio, which I was quite surprised, because I haven't been signing the app for quite some time, is quite easy. Like currently you can just do everything inside the Android Studio. There is one important thing which you have to do if you want to build a bundle. You have to export encrypted key, because this is how Google will later on create these different versions of your APK. And I'm pretty sure that bundles were already covered during the Instant Apps talk. So I'm not going to explain it to you, but I really enjoy this direction, that you don't have to put everything resources, but basically each device will get a smaller version of the big APK. So this is a pretty good thing. This is standard like signing process, so you just have to sign both like full version and instant version of your application. And this was like a brief. This is like a really pleasant experience. The unpleasant part of the experience starts inside the Google Play console, because if you want to test this full instant app process, you need to create a Google Play application, Google Play version of your application. You need to configure everything, and by everything I mean all the things which are which have tick marks, basically, which are now great. So basically it means if you even want to first test your app on your phone, or even if an emulator, but with the whole flow of how you will see this try now button, which is like regular for those instant apps, you need to go through this process. So I put it, I was hacking this, because I didn't even, for the sake of the conference, I didn't want to have it app icon. I don't need this sort of graphic for recommended section, everything. So yeah, everything was just made inside preview or whatever tools I had. I had to went through all those privacy terms and all those risks assessments which are related to releasing your app. Like deciding what kind of countries can use this app and what is the price of my application. So I think after 20 minutes of hacking in Play Console, generating all those assets, making screenshots. I finally made it through, so I was able to submit my application. So this is a success, because this beginning of your testing of your instant app, it's grayed out until you fill out all the necessary information. So I was able to finally upload my instant app, and this is what you will see. So once you go to this test track of your application, you will finally see this try now button. And this is all about instant app. So instant app versions, and you might have seen that already, there is a regular installed version and there is an instant version of your application. But what's really cool, and I don't know if you noticed that, because there is a way to invoke your app URL, and instead of taking you to this screen, this just automatically install your app without any interaction from the user. So yeah, fine. At the beginning, before you are, like part of this Play Instant, this is still like a beta, so you need to accept that you are part of this program, and then you can just basically test instant apps. And yeah, there is a video here. So this is what this is from, recorded from emulator. So this is like, once again, the screen. So this is like what shows up instead of installing. You will see that this progress loading information, that this is a Google Play instant application. And yes, now you will see the old version of the application, because the instant part I've done before. I created even this watch model and this layout for buying a watch. So yeah, so this is the whole process of instant apps. And for me, it was really painful. Like, creating an AR experience is a breeze. Creating an instant app version is like a nightmare. Yeah, and there are also limitations. So you need really to think about how you create your instant app, because you have only 10 megabytes in total. So your instant app has to have lower than that. And I think you can only download up to 15 megabytes of additional assets. So if your app downloads some sort of a mesh model, like a different watch, you need to also make sure that it's below that. There is a limited access to permissions, obviously, so they are quite limited those instant versions apps are limited in what you can do. So for instance, you can see that there is no Bluetooth, so you cannot make an instant app version for some, I don't know, like Bose headphones. Because it will not make sense. You will not be able to connect to the Bluetooth device. And yeah, so as I told you already, Google Play Instant is still in beta. So if you really want to publish a release official version of your application, you need to sign up to the program. I'm not sure how the process will looks like, because I don't have a need at the moment to publish anything. And yeah, so that's pretty much all. So as you can see, like I showed you the AR experience in probably like 30 seconds. This is like in total how much it takes to start, scan a business card and just watch a watch and then eventually buy it. But there are a few remarks which I want to share. And my private one is that I'm still a huge believer of Unity. So although we as Android developers, we can already use Java to write AR applications, but in comparison to Unity, which is like a fully featured 3D game engine, it's really, really painful. And Unity has already all those assets you can use for creating models, for your scenes, effects of your models. But yeah, the only downside is that you cannot make an instant app version with Unity. Especially in AR, because I think the lower you can get with the very simple app made in Unity is already around 10 megabytes. So there is not really, because the whole engine weighs quite a lot. There is a big size, around 7 or 8 megabytes already. So there is not much space left which you can use to create your AR experience. And another private remark is that it's not anymore about AR or VR. I would say that if you, and especially what I like about Android as well, is that there are many different kind of technologies which you can use together. And I think it's really good to think, especially thinking about those spontaneous AR experiences, of what you can use to create a really great user experience. So there is, IoT, because you can use a sensor and you can visualize IoT data. Like once the user comes to the factory, then he can, for instance, using AR, watch all the parameters of machines working, like temperatures or whatever else you can have there. Machine learning, there's also this Firebase Cloud Vision, which you can use to also analyze images, analyze face features as well. So what I would encourage you to do is just to think about what's already possible with Google's products families, and I think there is a lot you can combine and create some sort of even AR-enabled experience as well. And yeah, so that's more or less everything what I wanted to show you today. Yeah, I'm personally, although I'm not anymore working as an Android developer, I try to keep up with what's going on, and I think that the instant apps feature combined with AR is something which is really good. And I think it's really, most of the problems with VR AR these days is just people are not aware of what you can do with VR AR. So that's why I wanted to show you that using instant app is the way to leverage this experience. And yeah, so if you are interested in talking about AR, instant apps, VR, machine learning, then just shoot me an email. Or if we still have like 2-3 minutes, then I can answer some questions as well. Yeah.
Hello, thank you for the presentation. I have a practical question.
Yeah.
Imagine you have anchored an object in the scene in the AR. How stable is it? If you move around, how likely is it that if you come back to the place, for example, somewhere on the floor, that your object is still in the same point? How reliable is this?
Sure. So in general, so ARCore works. It analyzes the features. So it's not like this just finds something and just puts it there, and then it starts using accelerometer and gyroscope data to move you around. So it basically tries to recognize some sort of corners, edges, like very distinctive features in what was seen. So in my experience, it's like you might see some drifts. So once you start moving, especially if you are not looking at the object anymore, then there will be some drift. And you might have seen that when I was trying to see how this watch will look like on my hand. I put my hand and I started moving this hand. So it found some features, it was trying to follow those features, so that's why it just broke the experience. But if you just come back to the augmented image, like this will once again find the same features. And well, it's not only about augmented images, basically if you have a very distinctive pattern, I would say this sort of banner, this is something which is really good to start your experience. So if you put a content there, if you go away even to different room and come back 2 minutes later, but still in the same AR session, then the content will eventually adjust itself once again to this banner. So in general, it works well.
Okay, so I understand it doesn't imagine its own space, but just relies on the features of the visuals.
Exactly.
Okay. And another practical question, are there any SDKs that are accessed by web technologies, maybe?
Yeah, so there is another technology which is also promising, especially when we talk about spontaneous AR experiences. It's called WebXR. So all those capabilities of those new devices, so ARKit or ARCore, they can be accessed through web browsers as well. Like we have this already. Our browsers can access that Bluetooth in our phones as well, a camera as well. So currently, I'm not sure if it's already like publicly, for instance, available in Chrome or Firefox, whatever. There is already an access to those ARCore and ARKit APIs, and basically you can use WebXR in this regard to create also an AR experience. But the only difference and the only problem you will have comparing to what I showed you, that you will not have a native app, but JS app, JavaScript app, which will be limited. So there will be one thread, there will be some jitter, there will be definitely no physical based rendering inside. So physical based rendering is something which is part of this Google filament. So yeah, so in that regard, I think it's quite limited at the moment. Maybe in the future, it will kind of, like, there will be a small distinction between one and the other.
Hi.
Yeah, hi.
Hi. Thanks for the talk. I was wondering what are our options as developers when it comes to tampering somehow with the space perception module. Imagine a situation where you have a somewhat pleated surface or a situation where a part of a projected model would have been covered by some foreground item. Do we have any solutions that can actually deal with it?
So you mean like occlusions? So if you want to put your hand and you want to somehow limit the digital content, like to make it even more natural, that's what this is all about?
Yes, yes.
Yeah, so currently occlusions are not supported. So what you could have seen also in the video, that sometimes if you break the perspective, so if you put your hand in front of the digital watch, the watch will still be visible, which breaks the experience in a way. And currently there is no easy way to tackle this particular problem. So what I can say you about, like, totally outside of Google's ecosystem, that there is a lot of machine learning based research currently, which is used to tackle this occlusion problem. So basically, like, I don't know, have a Pokemon which just once it runs like behind the table, it just disappears. And it's in this regard, it's just made using pure machine learning rendering. So basically, you just feed the camera image, and the machine learning just basically really nicely, I don't know, clears the objects which shouldn't be visible. So that's how it works in principle. Like, definitely it's not part of any popular SDKs which I know about. So if you want to really tackle the problem of occlusions, you need to do it by yourself. But there are ways to do that. So for instance, I'm not sure how to do this in scene form, but I have an experience with making the same in Unity. So if you have like this sort of augmented image, and if you want to have occlusion, so you know that there will be some sort of animal that will be running, like thinking about this table, and there will be animal that can jump behind this table. So what you can do, you can put a cube, like a regular cube, like transparent cube, inside your scene, and like then you need to modify the render pipeline. This is why I'm not sure if you can do it really easily in Scene4, but in Unity you can modify the rendering pipeline, and you can use this transparent cube, which will not be visible to the user, that it will be basically occluding all the objects that will come behind it. So there are ways to do this. I'm not sure how you can do this. It will be pretty hard probably to do it in ARCore, unless you dig into the rendering pipeline, which probably you need to go to the C code as well, C++ code. But yeah, if you want to try something with this, I would rather recommend Unity at the moment.
Yeah, sure. I was aware of the fact that you have to make it yourself.
Yeah.
Only wanted to know if ARCore allows, how flexible it is when it comes to
so pretty
modularizing.
Yeah, sure.